Okay, welcome to part 2, year 12. Right, so we're going to carry on looking at this idea of finding derivatives from first principles, okay? This formula that we developed. Notice how this formula here is just very slightly different from what I did. I had a as being equal to x, but a is just a specific point along the curve. X is a general point along the curve. It's essentially the same formula. So it's basically finding the gradient of a chord by taking a point that's away from the point you're interested in, and then letting that point move closer and closer and closer to the real point, and taking the limit of that. You can't take the actual point because it will be indeterminate form. Okay, so you will be expected to be able to do it from first principles. Okay, so let's just have a look at a few questions here. So what I want to do is find the gradient of the tangent to the curve x squared plus x at the point 2, 6. So what I want to do is I want to find f prime x, the gradient function. Okay, so I'm going to use the formula. It's going to be f of x plus h minus f of x over h. So what's f of x plus h? It's x plus h squared plus x plus h. I'm replacing anything that's x with x plus h. Okay, minus x squared minus x, because I'm taking away all of that. So it's, there should have been a bracket. Hope that makes sense. Don't make mistakes with your negatives. All over h. Okay, and now expand and simplify the brackets. So I'm going to get x squared plus 2xh plus h squared plus x plus h minus x squared minus x all over h, okay, which simplifies to with x squared plus x and then minus x squared minus x, that cancels out. So we're going to get 2xh plus h plus h squared all divided by h. Okay. Now what we need to do is we need to take the limit of this. Sorry, I'm getting headaches here. As h tends to 0 let me just make sure it's done properly. I need to take the limit as h tends to 0 of this. Okay, and so what I can do is I can remove the discontinuity. So I can take h out, be 2x plus 1 plus h all over h. So that's, I managed to cancel away the discontinuity. And so I'm going to get 2x plus 1. Because as h tends to 0, that will just disappear. So my gradient function is 2x plus 1. So what is the gradient at the point 2, 6? Well, that has an x value of 2. So I want to find f prime of 2, which is 5. So the gradient of the function at that point must be equal to 5. Okay? Hope that makes sense. Stop the video and see if you can have a go at the other two. This one and this one. Okay? Stop the video and have a go. Okay, I hope you've done it. So let's just do the first one, x cubed. So you're going to get, we want the limit as h tends to 0 of x plus h cubed minus x cubed all over h, which is equal to the limit as h tends to 0 of x cubed plus 3x squared h plus 3xh squared plus h cubed minus x cubed all over h, okay, which is equal to the limit as h tends to 0 of, well, x cubes disappear. So what am I going to end up with? 3x squared h plus 3x h squared plus h cubed all over h. Okay, and now what I can do is factor out the discontinuity. So I'm going to factor out an h. I'm going to get 3x squared plus 3xh plus h squared all over h. So I can now cancel away the discontinuity. So now, as h tends to 0, well, all I'm left with is 3x squared. Okay, so f prime of x is equal to 3x squared. F prime of 2, so the gradient of the function at an x value of 2 becomes 2 squared is 4 is 12. So the gradient of x cubed at an x value of 2 is 12. Okay, same for the next one. We're just going to make sure we use a binomial expansion, do it nice and quick. So we want the limit as h tends to 0 of x plus h to the power of 4 minus x to the power of 4 over h. Right, won't bother with the limit bit because I just want to save time. So it's x to the power of 4 plus 4x to the power of 3h plus 6x squared h squared plus 4xh cubed plus h to the power of 4 all over h. Okay, minus x to the power of 4. So x to the power of 4 disappears, okay, it cancels away. And now I can factor out the discontinuity. So h lots of 4x cubed plus 6x squared h plus 4xh squared plus h cubed all over h cancels away. And so as h tends to 0, all I am left with now is 4x cubed, because 0 times anything is nothing. So the only thing you've got left is 4x cubed. So f prime of x is equal to 4x cubed. So f prime of 3 is equal to 27 times 4, which is 80 plus 28. So what's that? 108. So the gradient of x to the power of 4 at an x value of 3 is 108. Okay, so that's doing everything by first principles. Luckily for you, more often than not, we don't need to use first principles. Okay, you do need to know it because you might get asked a question to do it in first principles. But notice that x squared became 2x and x became 1. Notice that x cubed, that was when I was finding my gradient function. Notice that x cubed became 3x squared. Notice that x to the power of 4 became 4x cubed. Perhaps you can spot a pattern, okay? Just maybe stop your video and see if you can think about what the pattern is yourself, a rule that we can simply follow for finding the gradient function. But it's pretty easy. All I've got to do, so I've got x squared here, is, if this is f of x, to find the gradient function, all I need to do is take the power and multiply it by the coefficient's 1, so it's going to become 2, and then drop the power by 1. X cubed becomes multiply by the coefficient and drop the power by 1. X to the power of 4 multiply by the coefficient and drop the power by 1. Okay, so there is a rule we can follow. It's called the power rule. It's a very simple rule to follow. So we can say if y equals a to the power of x, a times x to the power of n, then dy dx, or f prime x, is equal to a n x to the power of n minus 1. So we don't really need to do things from first principles. We can simply apply that power rule as long as I have my function in the right, in index form. Okay, so for example, a very simple function, y equals 3x to the power of 6. The gradient function is 18x to the power of 5. Multiply the power by the coefficient and then drop the power by 1. Okay, very, very simple. Obviously what you need to do though is make sure you understand your rules of indices so that you can put things into a form that makes it easy. Okay, so what's f prime x for this first one? Well, that's easy. Everything's in a nice easy form. So that's going to be 15x squared plus 12x. Follow it through for when it's x to the power of 1, so it's going to become minus 3 because x to the power of 0 is 1. And a constant will disappear. If you think about it, x to the power of 0, it's the same thing. If I times anything by 0, it becomes 0. Okay? The second one, we've got a little bit of a problem. It's not in a format that we can use. We need to use rules of indices to be able to do it. So I'm going to change this to 7x minus 4x to the power of minus 1 plus 3x to the power of minus 3. Now I can simply apply the power rule. So that's going to become 7. Minus 1 times minus 4 becomes plus 4. Drop the power by 1. Minus 3 times 3 is minus 9. Drop the power by 1. And then put it back into the form of the question. So 7 plus 4 over x squared minus 9 over x to the power of 4. Okay? Let's have a look at the other two. So again, we just need to know our rules of indices. We're going to rewrite the original function as 3x to the half plus 2x to the minus 1. Now I can very easily apply my power rule. So 3 times a half is 3 over 2, x to the negative a half, minus 2x to the negative 2. Now put it back into a form of the question. That's going to be 3 over 2 root x minus 2 over x squared. Okay? Next one, we're going to rewrite g of x as x squared minus 4x to the negative a half, because I understand my rules of indices. So g prime x, the gradient function, is 2x plus 2x to the minus 3 over 2. Drop the power by 1. So that's 2x plus 2 over the square root of x cubed. You must know your rules of indices. Okay? Right, I'm going to stop the video there and then there's more to come.